during the discussion day. We're still having some people come in. The attendees number is still going up, so I'm just going to give it a moment for some of the not quite yet late arrivals to kind of enter in and get their systems up and running. Okay. Good morning, everyone. Well, good morning and good afternoon. My name is Alex Garbier. I want to welcome you all to our presentation today, and really want to thank everybody for joining us. We know everybody has a busy day and appreciate taking time out to discuss. We're in the midst of conducting a bunch of research, as I'm sure many of you are, about traffic counts, traffic volumes, and thinking about this question. And so this is part of an ongoing effort. And so we also want to make sure you're aware that at the end of this webinar, we're going to provide a survey where you can opportunity to give us some feedbacks. And we're really interested in hearing your thoughts. And those are findings we will present out kind of as we continue to engage in this topic and kind of moving our profession forward as we go into these new conditions. So just a couple of housekeeping items from the beginning. We're going to be doing a Q&A at the end of the presentation, and we have a chat box available for you to post your questions throughout the presentation, and we're going to field them at the end. Also, in keeping for, if you're following to do a PDH certificate and want to document this meeting as a professional development hour, if this activity meets the guidelines determined by the board of your particular state, when the webinar ends today, you'll be shown a survey. Make sure to take the survey, as that is where you'll indicate that you want the PDH certificate. So from a starting point, I think we want to start actually with a poll to get a sense of who's out there. And this is kind of a chance for all of us to get a sense for who's on this call and kind of what the makeup of our audience is today. So I'll just give a quick moment. We're getting our, this is very fast responses. I think we're up to 50% now. And give it maybe 5 more seconds. And okay. So we have 38% are public government agency and 52% consultant and 8% academic. And just as a note on the audience, we have about 700 audience members currently right now. So, sorry, without further ado, I just want to introduce our guides today for this presentation. We have Chris Brehmer, who is a senior engineer in our Portland office. We have Brian Dunn, who is an engineer in our Portland office, and we have Wayne Kittelson, the founding principal of Kittelson Associates and a longtime leader in the field. So without further ado, I'll pass it on to Chris, who's going to talk a little bit about kind of the observations we've made over the last couple months.
Well, thank you for that introduction, Alex. I think we'll be back to the actual slides here in a moment. I want to also extend my welcome to everyone here on the call today. This is pretty exciting looking at the registration. Before we started, I believe we had representatives of over 42 state DOTs and just a wide audience, as you saw from the poll. So thank you for joining us, and we look forward to your feedback. To begin today, I wanted to just provide a little context from a transportation perspective at some of the statistics we're monitoring and seeing across our offices. Begin here with the home state just because it's easy from our news. Wanted to show you some trends here in the state of Oregon with traffic volumes. These graphic on the left is a comparison to 2019 traffic conditions to 2020, showing the reduction that happened as first we transitioned to school closures and then the governor's stay at home, stay safe order. You can see upwards of 40% reduction that was kind of the low point. And now we're starting to see some trends where traffic volumes are slowly working their way up. The graphic on the right on your screen is a screen capture of data that the Oregon Department of Transportation has collected on Interstate 5 right at the Oregon-Washington border. And you can see over the last several weeks, certainly the big drop, but then a gradual increase in traffic as activities resume. Changing to the next slide, we'll show you a similar exhibit that the Florida Department of Transportation has provided. This is a graphic of the mid-April to mid-May period. And what you see here is both statewide data for trucks and vehicles, as well as national trend data for both modes. And you can see that things are slowly starting to move again. So we are seeing that trend. And as you look at your own agencies across the country, I think there's a lot of different dashboards and toolbox tools becoming available to monitor those trends. Switching to the next slide, this phenomenon is of course happening across modes. On the left, you see some of the transit modes from major transit providers around the country, anywhere from 60 to 80% declines in ridership as we all deal with social distancing and the many challenges that we as a society are facing. That trend also extends to airports. Portland Airport, like many others, has seen a phenomenal drop in traffic, unrivaled since the events of 9/11 back in 2001. And instead of standing in TSA lines, really the only lines we're seeing are parked airplanes. This is an image taken last week by one of our colleagues out at Portland International Airport, where one of the runways is simply being used to store planes that they don't have room for anywhere else. Transportation network providers like Uber and Lyft have also been affected. Interestingly enough, they're seeing some pretty significant drops and are going through layoffs. So we have that modal data. The next slide would share just a little bit about other trends we're seeing. Certainly anyone watching the national news is seeing the country in various fits and starts try to figure out how to reopen. And we've got cases like Georgia who've reopened statewide, and at the other extreme, we have agencies that are extending holds and asking people to stay home for additional period. From an employer perspective, that is having a significant impact on how we all commute, and probably everyone on this call can relate to that. There was a New York Times article this week that provided some interesting insights that we've captured here, where some really significant employers have taken different stances with Google and Facebook, essentially inviting their employees to work from home until next year. And you can see other employers listed that are extending either to midsummer or later, and in fact, in one case, permanent changes to that home to work opportunity. Part of the feedback in that article relates to the actual changes from an employer perspective, where for the first time we've been forced into this situation, and both employers and employees are finding some real advantages to working from home, and the article elaborates on that. Moving ahead, want to focus in now on what the purpose of our conversation today is, and we are going to limit it to really this question of traffic counts and how to deal with our current situation. And the next slide will show you our agenda. We are going to begin with an overview of the white paper that we prepared, and if you need a link to that, we'll be providing it on the side, but certainly invite everyone to read that. We will then look at some specific case studies that we've been working on and share some of the insights and experiences we've had there. We will then give Wayne Kittelson a chance to reflect from his perspective of career and transportation, what he sees moving forward, and then we'll wrap up with an opportunity for your questions and some interactive responses. With that, I will transition the conversation over to Brian Dunn to talk about our white paper.
Thank you, Chris. I was just going to take the audience here through the highlights of the white paper that we prepared back on April 2nd, entitled Estimating Traffic Volumes Under COVID-19 Pandemic Conditions. And within that white paper, we identified essentially a 4-step process to develop proxy volume estimates, as well as a series of different methods for developing those estimates. Beginning with step 1, establishing project context and data needs. On the next slide. These are essentially asking for the analyst or the expert doing the analysis. These questions may seem pretty intuitive. Essentially, to get to establishing your data needs, you need to ask a series of questions. What facility are you doing analysis for? Is it a system? Is it an interchange, a corridor, or perhaps a series of just intersections? Another question to ask is also, what are the modal considerations? Are you dealing just with vehicular traffic volumes, or are you dealing with trying to understand volumes for other transportation modes, perhaps transit, bike, and ped? Also, to understand what type of data is necessary. There's a number of different data collection methods now, from the traditional road tube counts to turn movement counts to more progressive data collection methods using video surveillance, drone technology, as well as big data or probe data that will be discussed here later in the presentation. And from that, understanding what are the critical analysis periods, understanding whether you need to be looking at just daily traffic volumes or something more refined, such as the peak hour. Moving on to step number 2, coordinating with public agencies. I think this is a very appropriate step for any project, public or private. We see this as an opportunity to develop a proper scope of work with the agencies, because we're engaged now in a time where we're trying to advance new data collection methods that are not traditional. We also see this as an opportunity to work with public agencies to either identify new case studies or to reveal case studies that have been done and validated. We're finding now that using historical volumes going back 2 to 5 years is proving useful, whereas most agencies' policies require data collection that is only 6 to 12 months old. We see this as an opportunity to explore more data with agencies. Departments within public agencies are not always centralized. You may have a public works department that has done a capital improvement project that was founded on traffic counts, whereas other departments in development review or planning have different resources. And lastly, we're seeing a number of public agencies amend their policies due to COVID-19. There's a couple of examples listed here of some early agencies that have made some adoptions. Moving on to step 3, identifying available data resources. We identify 2 target resources here. One is externally observed data using the traffic counts, essentially. I think most people, especially the consultants and the public agencies in our audience here today, are aware there are a number of traffic data collection companies out there. Showing an exhibit here from Quality Counts and the historical database that they've now provided online, showing where they have all road tube, turn movement, and video surveys across the United States. Public agencies also, many of them have their own traffic count programs that they keep online or internal. An example here is the Portland Bureau of Transportation, showing throughout the city where they collect all their historical data that is available to the public. We think there's more opportunity for public agencies, many of which operate their programs either in-house or provide limited data externally. Moving on to the externally observed data, there's a number of available studies out there. As I mentioned earlier, different departments produce different studies and review different studies. There's long-range plans and corridor plans available through different planning departments, and capital improvement plans that have traffic counts as their basis. In many cases, there's traffic impact studies for development projects that are available to collect and at least review the technical appendices for available traffic counts. Another resource we're finding that's very useful are the advanced traffic controllers. Some traffic signals are able to provide the vehicle detection data. And on the right side, you'll see a snippet of one such example where we were able to aggregate the traffic demand for individual lane groups over a period of several days within a month. Moving on to the second step, this is user-generated data or big data. It's data that's produced by emerging technologies that are using probe data from vehicles. That could be location-based GPS information, communication-based information from cell phones, Bluetooth, or even connected vehicles, which is a growing presence on our roadways. There are several traffic data aggregators and vendors out there across the United States. We're listing a few of those that are shown there. And moving on to the next slide. Within that white paper, we identified two methods for developing proxy volume estimates. And within the case studies we're going to show you today, we've also identified a third method. So I think at that point, I'll turn it back over to Chris so he can go over the case study number 1.
Thank you, Brian. So I'm going to begin with two case studies that are fairly typical traffic impact study type situations where we're trying to develop traffic counts. First one is in a project out in Hillsboro, Oregon. You see an aerial of it here with the site called out in cyan. This site is located in an area that's been developing pretty extensively over the last year. There's an east-west highway, TV highway that you see, as well as a north-south major arterial called Cornelius Pass Road. Those facilities have been in place for several years. In 2018, new roadway network was developed as part of a major community expansion, and you can see the outline of the new roads. East-west, there's a major arterial that is now parallel to the state highway and an extension of Cornelius Pass Road down to the new arterial. Those both play into how we end up adjusting traffic counts for our site. Moving on to the next slide, what you see is an aerial image of the 4 key study intersections around our property, shown with a gold star. These are the intersections that we're trying to develop traffic counts and an operational analysis for, mix of both signalized and unsignalized intersections. And you also see Katie Car Wash across the street from our site, and we'll come back to why that's important. Moving to the next slide, we were able to work with the city and the state to identify all of the traffic counts in the area that were available historically. The gold stars represent traffic counts that were conducted in June of 2018 before the new road network opened, and then again in October 2018 after the new road work opened. The blue stars show where traffic counts were available, but dating back to 2013. Moving on to the next slide and zooming back into our site, what you see is an aerial looking at traffic conditions back in 2013 and 2018. We know we have those 2 periods and we're trying to understand what might be different. And so as you look at that aerial on the left and right, you can see the car wash was one development that was added, not captured in the 2013 counts, but is captured in the 2018 counts. So we need to think about how to reconcile that. There's others also road network changes. As I mentioned, with the new roads happening to the south, that actually directly impacts our study intersection where the traffic signal is at 67th and TV Highway. What was a traditional 4-legged intersection with a railroad crossing on the south side is now a 3-legged intersection with the railroad crossing being removed. So we're trying to put these pieces together and develop traffic counts. We started at the signalized intersection because that was the one of the 4 locations that had the most recent data. And it was unfortunately only from June of 2018 before all the road network changes happened. So we started with those June traffic counts and then tried to use all the data from the surrounding intersections to estimate how traffic would reroute and what the new routing might look like post construction of the new roads. That gave us a base volume that we were then able to apply a historic growth factor towards to get it up to 2020 conditions. And at that point, we paused, hoping to compare to traffic signal controller technology data derived similar to what Brian discussed earlier. The intersection is equipped with an advanced traffic controller, and we were excited to request the data and see what was available, only to learn that unfortunately the data wasn't being collected at that location for some technical reasons. So this was an instance where it didn't play out to be able to use that advanced traffic controller data, and we had to stick with the toolbox that we had available. Once we developed counts at that location, we extended it to the other intersections, and that brings us really into the next case study of, well, how did we deal with the Katy Car Wash and historic data? One of the things we're finding is that we're having to basically come up with our own traffic counts when the land uses have changed. And so I'm going to show you very briefly an example that's being prepared in our Virginia office, where they are looking at a site shown here and have a mixture of historic traffic counts at certain locations for peak periods, other locations for daily traffic, and then locations particularly starred in with the red where they've got study intersections but no traffic counts. For those red intersections, what they're doing is trying to approximate traffic counts, and they're going back to our traditional traffic engineering toolbox. We're using trip data from the trip generation manual published by the Institute of Transportation Engineers to get a sense of how many trips should be going in and out of the different land uses, and then using that to develop traffic counts. They've basically broken the area down into a number of zones and are simply doing a development by development assessment of trip generation. And as you can see in the map here, using a traditional method of saying, here's the number of trips that should be going in and out of single family homes or other land uses on the corridor. So those are a couple of practical examples of just good old fashioned traffic engineering being applied. Going to now transition it back to Brian to talk about some of the more advanced approaches.
Thanks, Chris. I'm going to walk the audience here real quick through a couple more cases. Case study number 3, this is for a private development in Clackamas County, which is at the intersection of Oregon Highway 224 and Southeast 82nd Drive. That's the intersection that we're currently doing analysis for. And in this, if you move on to the next slide, and the one after that, I think the important information we wanted to summarize here is that at this particular intersection, we did do a traffic count in the middle of March. This is back when the COVID-19 conditions were starting to stunt the traffic demand patterns on the street systems. So in this situation, we recognized that we could take these traffic counts and adjust them to reflect pre-COVID-19 conditions. The data available was, we did have advanced traffic recorder data at the ODOT signal at this intersection, which is the graph shown on the right. We were able to take that information and not only aggregate the demand for the day the count was done, but as you can see in this first table here, that ATC information, we were able to look back in time for the month of February before COVID-19 impacts were realized, and look at an average of all midweek days for the month. So from this pattern, if you will, this proportion, we were able to identify percentage growth factors that we could apply to the individual months of the intersection. And that's what we've done here in the second table below to show how we've developed the proxy volume estimates for this particular case study. I think we'll move on to the next case, case number 4. This is dealing with the second method that we've presented in our white paper, which is dealing with big data, probe data from vehicles. We're going to show you 2 samples here. Sample number 1, this is an effort by some of our colleagues in Florida who looked into the use of probe data working with streetlight. This was about done in 2019. The intersections here that were selected for this study were in Central Florida along US 192. And in this instance, they picked a small, which is a lower volume intersection versus a larger, higher volume intersection. And throughout that analysis, it was a learning process to discover kind of what are the strengths and weaknesses, if you will, of using probe data. And I think the general pattern that we saw from this effort was that at smaller or lower volume intersections, we may develop a higher degree of error in comparing actual counts to the calibrated probe data. In the next example, this is a project that's ongoing right now in Oregon City, where we have collected turn movement counts for several study intersections in the afternoon, and we're looking to apply probe data also. We've collected that data for the month in which the counts were collected, as well as prior months over the past year. And from this effort, we were able to glean some initial findings. If you go to the next slide, that we're seeing certain advantages and disadvantages. This is a promising technology. I think that's what we're finding overall. And as far as advantages go, we're seeing that the using probe data is easily scalable across large areas, can be attained very easily. And I think the power lies in that this data is not just for a particular date and time like a traditional count, but that it covers a long period. It can be aggregated over days, months, and years. The data can also be obtained quickly and retroactively. Some disadvantages that we're seeing is that probe data may lack some compensation for heavy vehicle percentages and perhaps pedestrian and bicycle volumes. And in some cases, it can be costlier depending on the size of the project that you're working on. One of the things that we do stress is that that using probe data, that you also try to collect traffic counts, at least in the vicinity, for calibration purposes. And while we see it's not yet a widely accepted practice, it is a practice that's accelerating in its use. And so we're seeing a lot of promise from this technology going forward. I think at this point, we move on to the next slide, and we're dealing now with, before we move on to Wayne Kittelson, we wanted to address the 2 poll questions. Where's your organization right now in respect to proxy traffic volumes? If you could please select one of those. So I see we're collecting responses right now, and we have about just over 30% of the vote coming in. Maybe a few more seconds to give people a chance to vote. Got about half the responses here. So what we're seeing here in terms of the answers, the bulk of the audience is saying that they are thinking about developing guidelines for developing proxy traffic volumes. If I recall earlier, there was probably 30–40% of the audience were public agency officials. So that tells me that this is a pretty strong answer to the current condition with COVID-19. Looking into poll question number 2. What data resources are available in your area to use in developing proxy volume estimates? In this situation, if you could please check all that apply, and you don't have to limit yourself to just one item.
Hey, hey Brian, it doesn't work. We can't click.
Oh no. Well, I'm seeing here from the poll that 30% have already voted, so it may be limited to specific individuals. So if you could please keep trying. We're about halfway. We at least have about a 50% capture here.
If you go out of the presentation mode into the Windows mode, it'll let you vote.
Okay, we're going to show the results here. Pretty high percentage pattern, 84% are saying that historical turn movement counts are the most prevalent resource available to developing proxy traffic volume estimates, as well as road tube or loop detector counts is actually about the similar percentage. Looks like this is actually an interesting find here at 38% that appears to be many agencies have advanced traffic controller data available. Also, big data seems to be a percentage now that's creeping up at 47%, as well as traffic demand model estimates. So pretty wide variety, pretty good split between all these resources. I think we're going to move in here quickly to poll question number 3.
Ryan, that was poll question number 3.
That was question number 3.
I just want a quick note. I think at the beginning I had said to submit your questions through chat. I forgot that there is actually a specific questions options in the meeting software. So if you could submit your questions through that, that'll make it easy for us to track and be able to answer questions, even if not right now, something we can make sure in our follow-up materials that we provide.
So I think at this point, are we looking to turn this over to Wayne Kittelson? Take it, Wayne.
Thank you, Brian. We rely on historical traffic patterns not just to assess existing conditions, as we've been talking about, but also to establish a future baseline. And when we talk about future conditions, we typically do it at 3 broad levels: the near term, which I would define in the 1 to 5 year time frame; the midterm, which I would define to be 5 to 15 years; and then the long term, which would be beyond 15 years. So with respect to near-term projections, I think it's safe to say that the past is no longer as good a predictor of the future as it was prior to the start of this pandemic. Evidence is already coming to light. I think Chris showed some of that even after stay-at-home orders are lifted, we're going to see some short-term, long-term, and even permanent changes in fundamental trip-making characteristics of trip generation, trip distribution, mode split, average car occupancy. For example, businesses and citizens, I think, are going to continue some of their modified behaviors, which will probably lead to more telecommuting, possibly also more single occupant vehicles. Social distancing has been integrated into virtually all activities that we undertake, which I think will continue to affect mode choices and travel patterns. Beyond this, there's also the real possibility of an economic contraction or even a recession in the coming months, the effects of which could be with us for quite some time. So if you agree with any of this, then you might also conclude, as I have, that historical patterns are not the good baseline they once were to use for predicting the near-term future. And if that's the case, then what can we as practitioners do to develop the best possible predictions with respect to near-term forecasts? Well, I think our profession has always been good at innovation, which means we've been good at finding ways to use the tools and resources that are available to us in new ways to solve new problems. So in that respect, I start with what I think we do know, at least about the near term. First, I think it's reasonable to expect that population and employment is going to remain the same, both in size and location, at least in the near term. This means that the producers and attractors of trips aren't going to change location very much during this near-term time period. Second, I think it's reasonable for us to expect that people will continue to make 3 basic trips types: home-based work, non-home-based, and home-based other. They'll just be making these trips at different trip generating rates by different mode splits and perhaps using different trip chaining behaviors. We already have a variety of travel demand models we can use as tools to estimate what happens at the link and even at the intersection level, with different assumptions of trip production, trip attraction, mode split, and trip chaining. So if we combine these with a scenario planning approach to evaluate worst case, likely case, and best case conditions, then I think we can still provide good information to decision makers who are still going to need to make transportation investment decisions. Now, these are just my own initial ideas, and I'd welcome your critique as well as your alternate suggestions for how this near-term predictive problem might be overcome. But let me go now onto that second slide. So if we look beyond the near term to the midterm, which I define to be the 5 to 15 year time frame, things become a little foggier. But time also has a way of dampening the effects of an event like this pandemic. I think it's reasonable to expect that this crisis will be more of a memory by then. So some of the behavioral changes going on right now will have dissipated. For example, people will be back to more of a routine work schedule. Imperative for social distancing will at least have moderated in some way. Even so, I think there's still going to be some very significant transportation effects remaining that we should be taking into account in our midterm projections. First, businesses and individuals will have taken real steps by this time to minimize their risk of being caught unaware and unprepared again. These steps are going to affect both the location and the size of population and employment bases that we use as the foundations for our predictions. Second, it's already clear that people and businesses have learned things that they intend to carry forward even after this crisis has passed. For example, the crisis has had the effect of accelerating the adoption curve for new technologies like video conferencing, file sharing, public involvement, and participation. These are all things that I think were inevitable in the long run, but their adoption has now, I think, been accelerated. So when developing midterm projections, here's what I'd suggest right now. First, I think we can go back to relying upon a single kind of most likely scenario when applying our travel demand models, because we'll have opportunities to update as the horizon year gets closer. Second, we can ignore the current economic predictions because their effects will balance out over that 5 to 15 year time frame that we're looking at in a midterm time frame. Third, I think we should move our assumptions regarding the telecommuting square feet per employee, population and employment relocation decisions forward by about 5 to 10 years. In other words, the conditions we were expecting with respect to these factors 15 to 25 years from now, I think are going to be in place within that 5 to 15 year time frame. And finally, let me go to my last slide, the long-term projections. The foggiest prediction, of course, is this one. The good news is that it was always just about as foggy even before this crisis. So I don't think a lot of changes are necessary to what we're already doing. The one thing I'd suggest that we think about is to revise those 20-year assumptions we made about technology-driven changes, as well as population and employment location decisions, in line with what I was talking about earlier. Again, I'd consider using these projections for my 5 to 15 year forecasts and then extrapolating them out to the new long-term forecast, because the accelerated adoption that I think is occurring because of this crisis makes that, I think, a reasonable approach. These changes can actually be pretty substantial because they will affect not only travel demand levels due to like telecommuting, but also travel demand patterns due to revised location and size decisions that businesses and individuals are going to be making with respect to the location of their homes and their businesses. So I think that's enough discussion for me right now, and let me turn it back to Alex to conclude. Thank you.
Yeah, thank you, Wayne. I'm going to say I really appreciate the questions that we're receiving. Please keep them coming. We're going to make our best attempt here in the next 20 minutes to get to as many of them as we can. But in the meantime, if we don't get to questions, these are still really helpful, I think, for giving a sense of the types of issues that people are running into and future focus efforts for the field to kind of keep working at as we go forward. So I wanted to start with a question that's a little bit more of a general question, but how has our experiences so far, how has led to reconsidering of the types of approaches we might use, even if we were to go back to what kind of used to be the normal? I know we've laid out some new approaches. Has this led any of you, maybe I'll pass it to Brian first, to rethink kind of approaches that we might have seen as traditional approaches?
Sure, just turning my camera on here. Yeah, I think certainly I think one different approach, and something that I mentioned here earlier, is the use of like advanced traffic controller data I think the power of that data, as well as the probe data that we were discussing, is the ability to look back in time over a course of many different data points, many different days, months, and years. And I think that's very much a strength of using that information, because as we all know, I mean, traffic demand can vary from one day to the next. It can vary based on seasonality. And I look at traffic counts, traditional traffic counts, is really, those are just a snapshot in time of one particular time when things could be going on plus or minus 10% on any other given day of the week. So I think the more that we can rely on the ATC probe data and eventually move to relying on those technologies more, and having more breakthroughs with the calibration of that data, I think is going to prove very useful going forward as a permanent fixture of our toolbox as traffic engineering professionals.
You know, let me add to that. I think in the long term, you're probably right, Brian, but I still have a concern right now that that we might be making a mistake if we're trying to recreate what was using the historical data that we now have. Looking into the past, as I said, I don't think is going to be a great predictor of where we're going to be and where we're going to be in the long run. So as I talked about, the travel demand models and doing that kind of scenario planning approach is one way to address that issue. I think we're already seeing some examples of this, but one thing I wanted to mention, I think of course, once we start getting data, we'll see that after we come out of the pandemic. We'll be able to record and see where we're going. But right now, I think one way to get an early indication of what might be happening is through a stated preference survey of businesses. They've been in that mode. Chris showed us data that shows they're starting to come out of it. They're starting to what happens after they come out of the crisis. I think this is a good time to do that, and we're actually trying to. We've set up a survey, a 3-5 minute survey, to just inquire how people's travel patterns, how they see them changing post-crisis or post-stay-at-home kind of conditions. And I think if we were to use that, perhaps on a state-by-state basis, we could get, as professionals, some early indications of how travel patterns as well as travel demand levels are going to change post-COVID crisis.
Yeah, so one question that we received that I know is a bit of a tricky one is thinking about for rural situations where we might not have historical data, or where probe data may not be, it may be impractical due to low volumes. I think we're getting a question of what are other approaches that we are starting to hear or think about. And I'll pass that to the whole group, because I know that's kind of one that is an interesting but maybe a difficult question.
Maybe I'll start and just say I think part of it really comes down to what is the question you're trying to answer. I think certainly collecting data right now is very difficult and in many cases can't be done, but I think it does beg the question of what are we trying to answer, and is it something that, for example, we can use the land use data and try to approximate for a sub area what's there in combination with historic traffic counts? Or is it something that if it's a really low volume road, can you go to more of a safety, basic operations, geometric design based solution and not necessarily need a delay or capacity based analysis? So very valid question. And I think it really depends on what are you trying to do with the data. Hopefully that helps and gives Brian and Wayne a little more time to think of something to add.
No, I agree with what you're saying. You could take those same techniques that you were suggesting, Chris, or using in a more rural kind of environment, and maybe you have the flexibility there because you want to use the tools that are available to you. So you could use that same kind of information, but then maybe apply that scenario planning approach of worst case, likely case and best case in order to bound the problem, and therefore be able to identify which of these mitigation needs do I have to do under any circumstance, which of these mitigation needs maybe aren't going to be necessary. So maybe I can have some time to kind of check and see what actually happens before I pull the trigger on them. That's one approach. And again, I like the, I'm going to say it again, I think this stated preference is the tool I have right now, or the tool that we ought to be using right now, a stated preference kind of survey to get a sense of where people are going. So we as engineers and planners are not just working in the dark, but have some vision of where we think things are going for those predictive needs that we have.
Another question, this is, oh, sorry, Brian, do you want to?
I was just going to say, I think, expanding our toolbox of options, expanding and doing a detailed assessment of what data is really available. I think what we're finding on the projects we're working on is everything is really case by case. A lot of the methods that we presented here and that we're talking about now are almost like a hybrid approach of using all of these tools or all of these data resources. That's what we're finding.
One of the questions is, this would be a specific from California, but I think this group is well prepared to provide some thoughtful commentary on it, is a question of moving to VMT that both in California and in other locations, there's been an increasing focus on thinking about travel impacts from a VMT perspective. And so it's kind of a two-part. One, in the near term, how do these approaches potentially work for estimating VMT? And then in the long term, how do we feel, are there any thoughts on how VMT might change in the long run and how to keep track of changes in VMT?
That's a good question. I don't know that I got a great answer, but when you start talking about VMT, then it's not just the number of trips, but it's the length of those trips that also comes into play. And I'm thinking right now, what I'm thinking is, okay, I should probably look at breaking those down by the type. It's the type of trip why is a trip being made? It's the home-based work, it's the home-based other, it's the non-home based. And in each one of those, I think I might see a different kind of profile of how drivers, what options are available to them on those. And so therefore what they might do. This gets to that question of more potentially some of those trips might be more single vehicle occupancy trips. On the home-based work trips, that's where I might see the most on the telecommuting, right? Or alternative modes like biking with e-bikes now. E-bikes provide a greater range than bikes had before, so they become a competitive alternative to transit and the traditional vehicle over a longer range. So I might see a stronger surge in that. If I think about social distancing, the single occupant vehicle and bikes are, in my mind, probably the ones that would come out as the safest from a social distancing perspective for people to use, at least in the near term. Those are considerations I'd have to take into account, but it's a good question about how do you put all that together to finally develop that final estimate of VMT. Chris or Brian, do you have thoughts, or Alex for that matter?
Yeah, I guess I will say that I know a number of the big data firms. I know Streetlight has rolled out this product of thinking also about using probe data as a way to estimate trip volume, which really tube counts may not be as well set up to do. And I think there's also a question, I'm just going to take it now that I have the opportunity. I think there's a question about validating probe data. And I think this is something that we've seen a lot of promise, but I think one thing that we want to stress in some of the work that we've done with data firms is having even a nearby counts in order to be able to calibrate, or just kind of get a gut check on the type of data that you're seeing is really something that we see as critical, because there's a lot of promise, but both for your own confidence and also for clients, I think that's something that we've seen a lot of promise with. I'm going to go on to another question that I found really interesting was, I think we have a tradition of thinking about peak travel demand in a very specific context. There's some great rules of thumb for estimating peak demand. And the question we received is it time to kind of rethink what demand peak might look like on our roadways, both for personal vehicle travel, but also for transit or alternative modes of transportation?
So I'm going to say yes with an exclamation mark. I think that's exactly right. This is these times of chaos create great uncertainty, but it's times of uncertainty when we really do have an opportunity to rethink how we're doing things and what's the right way to do it going forward. So I see it as actually a great opportunity to rethink that. The transportation profession has always kind of been in a pioneering role because we're always kind of adjusting to behavioral changes, technology changes, things like that that come along. And this is just one more example of that. Yeah, so peak period travel patterns again might change. I can't say for certain, but that's where I would use a tool like a stated preference survey to start getting some sense of where that is prior to the actual observation of it that we do with data collection.
Alex, I may offer also that we're seeing, even though traffic demand's down quite a bit, as Chris showed earlier in some of those graphics, that demand is actually kind of starting to pick back up. And a lot of the public agencies, DOTs, are doing weekly updates on their websites, monitoring traffic demand patterns and how they're actually changing, week to week even. And I think it's clear from even the graphs that we threw up on the screen earlier that you're seeing a suppression of the actual peak periods of the day. And I'm speaking mainly to traffic now, and a spreading out of that demand over off-peak periods. So that's a pattern I've seen immediately as a result of this. I think the question is now are those peaks going to start either kind of percolating back into the picture as economies reopen? Maybe some folks, go back from the home-based office back to their office in the downtown area. So there's a lot of resources out there through the state DOT websites and local cities that are monitoring this on a week-to-week basis.
One other quick thing I'll add is I think it's not just peaking that's going to change, but I think mode choice is going to change. I don't know about you all, but walking around my neighborhood, I see people I've never seen before out walking and biking. And I think there's a lot of people discovering an aspect of transportation that we'd forgotten about.
Yeah, I think I can attest to that. I know here in Oakland, there's been a number of street closures, and I was yelled at the other day in a positive way for one of the first times while running of way to take back the street, which totally threw me off. So kind of an exciting moment.
It may also be purpose that changes a little bit as well during that period. I mean, if you end up, you may not actually see a big drop in volumes if the telecommuting trips are replaced by more discretionary trips that people are now making during the peak hour that they were putting off because of the congestion that was occurring before. So there's all of these factors playing in, which again is why I think travel demand models are such an important tool for us to use in this environment.
So I want to note that we're going to try to take maybe one, maybe two more questions, but in the meantime, just for anybody who got a little bit of late start, there is the potential for a PDH credit. I know we're getting questions about that. There'll be a survey at the end of this meeting where you can request that information. Also, we'll be posting a recording of this talk in case you want to share or just reference back. We'll also be looking at these kind of questions they've been receiving. We're continuing to do work on this topic, and we'll kind of continue to report out. So just want to say, please keep following back with us. And, we're always happy for any feedback for us so that we can make sure that we're giving the most up-to-date and interesting information for these talks. So one question that I wanted to also get back towards is if there's any recommendations for developing areas. I know we had the example from in Virginia of a new development and using land use patterns for growth. I was wondering if there are any other considerations that might be worth making sure people think about when they're doing estimations for new development or fast-growing areas?
I think a
Well,
cautionary
now it's
note
gonna
that
be-
I'll throw out is maybe just, I shared the example of using IT trip generation for estimating land uses. I think that's a valid approach, but particularly if it's a large area, you need to really be careful not to double count trips and just keep in mind the sample size of what's available in ITE's resources and what we're applying it to. And that may lend itself to what Wayne was describing a moment ago of looking more at travel demand model or travel demand model based thought processes in developing volumes for large developing areas.
Mm-hmm.
Yeah, trip generation rates that are in ITE may change because of the telecommuting, right? But or other factors like this peak hour spreading or such. But it's also going to depend on whether that newly developing area is contiguous to a big urban area where they have other mode choices, or if it's out in a remote area where the number of choices of options for travel modes are limited. So that would be a factor I'd think about as well.
Mm-hmm. I think the only comment I probably would add on this, particularly for a developing area, is for either agency officials or consultants who are in the audience to be wary of what developments maybe have already been approved or in process right now. Because like what we saw with the last recession is that you may have a lot of projects that have been approved for permit, but either because of recession or reduced economic activity, some of those projects may have stalled out. So I think it's important to keep monitoring, where those projects are that are either like down the way from a particular location that they may be looking at developing.
I think kind of maybe following on this, another question that we received is about when it may make sense to do retiming of signals. Retiming either to accommodate perhaps increased pedestrian volumes or retiming due to fundamental change in traffic patterns that may be near or not so near term.
Probably case specific again, but I like the notion, I like the idea, I like the thought of thinking about those kind of things, because even as, for example, one of the things you can do with signal timing or those kind of issues is you can kind of promote certain policies or promote certain modes that maybe people are showing a tendency to want to use if they can, such as timing them more for the pedestrian or the bicycle. The active walking modes might be a higher priority than it has been in the past in some locations. In other locations, probably just making sure that they're efficient and operating in a sort of a system-wide progression way as we do currently is probably sufficient.
Okay. Well, I just want to thank everyone for attending today. We really appreciate taking time out of your schedule to join us. I also thank Chris, Brian, Wayne, and all the people at Kittelson who've helped put together this go-to webinar. It definitely goes beyond just the four of us. So much appreciated, and hope everybody has a great day and get a chance to get outside. All right. Thank you very much.
Bye. Thanks, everybody.
Thank you. Bye-bye.
Thank you.
Thank you.